Hello, I'm going to show you the correct way to do some algebra problems. Let's motivate these things. For example, if you had 3 into 12, you would say the answer is 4. And you were taught to check that 3 times 4 should equal 12. Just like if you have 6 into, 6, 12, trust me, the answer is 102. You would multiply those two values and you would verify to see if you get 612. But there's other ways of writing 3 into 12. Another way is 12 over 3. 12 over 3 and it should equal 4. Remember, 3 times 4 is 12. That is, this product should equal the top. 612 divided by 6 is 102. Or isn't. Maybe we made a mistake. So you would multiply those two numbers and you would say, nope, it's correct. Okay, so let's look at this rather carefully. We know this equals 4. So this product should equal 12. But you know what? If I switch the 4 into 3, we still have equality. That is, 12 divided by 4 is 3. Only because this product is still equal to 12. That is, you can switch these two numbers. So if somebody gives you 15 divided by x is 4, this is a very simple procedure to get the answer. Just swap these two. 15 divided by 4 is x. And since 15 divided by 4 cannot be reduced, we're done. If you have 12 divided by x is 4, you can swap those two and you get 12 over 4 is x. But I can reduce that to 3. If you have 16 over x is equal to 10, just swap these. And x is going to be 16 over 10. Since both of these numbers are even, can certainly divide the top and bottom by 2. So that's the answer. Very simple. Now, here's a problem that really interests me about how people do it. If you have this, most teachers will tell you to cross multiply, that is, multiply the 7 with the x and say that is equal to 5 times x plus 6, and then they will tell you to distribute. You have 5x plus 30 is 7x. Well, that must be 2x's. This 5x plus 2x really equals 7x. You want to take away 5x from both sides, go for it. But either way, 2x is 30 and x is 15. 2 times 15 is 30. That is way, way too complicated in my opinion. Much, much too complicated. These two differ by 6. In fact, the bottom is 6 larger. I mean, after all, if you take the top, which is x, and you add 6 to it, you get the bottom. The bottom is 6 larger. Okay. Now, on the right side, the bottom is only 2 larger. Well, if you multiply 2 by 3, you get 6. I'm going to multiply this right fraction by 1 as 3 over 3. And I get 15 over 21. Notice the bottom is now 6 bigger than the top. Now you can say the top equals the top. X is equal to 15. You can also say that the bottom equals the bottom. Some number plus 6 is 21. 15 plus 6 is 21. X is 15. X is equal to 15. Look at the work I did over here. Look at the work I did here. Another problem. Assure your teacher that this is the way you do these problems. If you have x plus 2 over x plus 10, so the bottom is 8 more. So if you have 3 over 8, the bottom on the right side is only 5 bigger. So you multiply the top and bottom by 2, with 5 times. Okay, well, I had different numbers in my mind. Suppose you have 3 over 5. So the bottom is only 2 more. Well, we want it to be 8 more. So I'll multiply by 4 over 4. I'll get 12 over 20. The bottom is 8 more, just like on the left side. So you can say x plus 2 is 12, or you can say x plus 10 is 21. Either case, you're going to get x is 10. Some number plus 2 is 12. That number is 10. This is certainly the way to do such problems. What if you have 3x plus 5 over 3x plus 1? So the top is now 4 more. If this is equal to 3 over 2, the top on the right side is only 1 more. To get it to be 4 more, multiply by 1 as 4 over 4. 1 times 4 is 4. So now you have 12 over 8. Oh, the top is 4 more. So you can equate the bottoms. Some number, 3x plus 1 is 8. That, of course, is 7. Everyone knows that 7 plus 1 is 8. So 3x is 7. X is 7/3. Let's do one more. This one will be a little bit harder. Suppose you have x plus 2 over x plus 5. The bottom is 3 more. Well, what if you have 3 over 5? The bottom is only 2 more. What do you multiply 2 by to get 3? Well, divide by 2, that gives you 1, then multiply by 3. Multiply top and bottom by 3 over 2. You want to do 2 times what is equal to 3? Wonderful. You need to be able to come up with your own linear equations. So I'm going to multiply by 1 by 3 over 2 over 3 over 2. The top will be 9 over 2, and the bottom will be 15 over 2. And just for the record, 15 over 2 minus 9 over 2 is 6 over 2, which is 3. That is, the bottom is 3 more. Wonderful. So the tops can be equal. Some number plus 2 is equal to 9/2. That is 4.5. You should know that 2.5 plus 2 is 4.5. So x is 2.5 or 5/2. That's the way you solve these type of equations. Now, just for the record, if you have x plus 2 over 2x plus 3, The bottom equals some number. It's equal to 4 over 5. The bottom is not a number larger or smaller than the top. That is, if you were to subtract them, you get x plus 1. The bottom is x plus 1 larger. So, I can't make this right side, can't make the bottom x plus 1 larger. Why? Because I don't know what x is. And if I knew x was 4, 4 plus 1 is 5, I'd make the bottom 5 larger. But then again, if I knew x was 4, I would just come right here and go, x is 4. But I doubt that that's right. Okay, so this technique will only work when the top and the bottom just differ by a specific number, not an unknown. Not an unknown. That is, if you have 7x on the top and 7x on the bottom, and then you add or subtract some, then I can tell you how much bigger one is than the other. The bottom is 7 bigger. So, if this is equal to 4 over 5, it's a piece of cake. The bottom is 1 bigger. To get it to be 7 bigger, multiply by 7 over 7. And you get 28 over 35. So either this is 28 or this is 7 more, 35. If I go 7x plus 4, 35, you should know that's 31. 31 plus 4, 35. So 7x is 31, and x is 31 over 7. And you can check this pretty easily. 7 times x, 31 over 7, take away 3 over 7 times x, this is how I write x, plus 4. All the 7's are going to cancel, so on top you get 31 minus 3, which is 28, and on the bottom you get 31 plus 4, which is 35. I can divide the top and bottom by 7, and I get 4/5, just like the original equation said. That is how you solve these rational type equations. The whole thing is that the top and the bottom, they have to have 7x. Now, it doesn't even have to be x. It can be x squared. 3x squared plus 4 over, it has to be 3x squared plus 3. So now the top is 1 bigger. So you have 5 over 3, while the top is 2 bigger. 2 divided by 2 will give you the 1. Make it 1 bigger. So I divide by 2. And I get 5/2 over 3/2. So this equals 5/2. This or that equals 3/2. So 3x squared plus, now when it comes to 4, I'll multiply it by 2 over 2, multiply by 1, so now I have a 2 on the bottom, just like the right hand side. Bring those over, you have 3x squared is negative 3/2. The left side is very, very, very friendly to divide by 3. That gives me x squared. But I don't want to divide that fraction by 3, so I can always multiply by the reciprocal. And 3 goes into 3 one time. Negative 1 times negative 1 is negative 1 over 2. Now, nothing when you square it. No number when you square it will give you negative. So in this case, there's no solution. This case, no solution. But it could have worked out. It could have worked out. For example, if I just made it equal to 15 over 13. So I divide by 2, like I did over here. I'll get 15 halves over 13 halves. So I can say this numerator is 15 halves. You should know that 7 plus 8 is 15. So this should be 7 halves. Because when you add 8 halves, you get 15 halves. So 3x squared is 7 halves. To solve for x squared, very, very friendly to divide by 3. But on the right side, I'll multiply by a third. So I get 7/6. What number or numbers, if any, when you square then gives you 7 halves? The answer is plus or minus the square root of 7/6. If you don't, and this answer is fine. If you don't like radicals in the bottom, that is, if you want to change the way that looks, you multiply by 1. The representative for 1 I'm going to pick is square root of 6 over square root of 6. So on the top, I get the square root of 7 times the square root of 6, which is the square root of 7 times 6. 7 times 6 is 42. And the reason I picked that representative for 1 is because the square root of 6 times the square root of 6 is simply 6. So x is equal to either positive square root of 42 over 6 or negative the square root of 42 over 6. So it will even work if it's nonlinear. What has to be the case is that this is the same. And we can get more ridiculous. We'll see how far I go with this. But you can have 3x squared plus 4x plus 2, 3x squared plus 4x plus 5. The bottom is 3 more. So if I give you 7 over 8, so the bottom's only 1 more. 1 times 3 gives me 3. So I want to be 3 more. Multiply by 3 correctly, and I get that. So I can now say this numerator is 21, or the denominator is 24. So 3x squared plus 4x plus 2 is 21. Now you can bring this over and goes 3x squared plus 4x take away 19 is 0, and you use some techniques to solve that quadratic factor by grouping, completing the square, using the quadratic equation, factoring, I don't know what you call this, but factoring by like guessing. You want to put two numbers here that multiply out to negative 19, and when you multiply this number by 3, there's an understood 1 here, and this number by 1, you get 4. It's a lot easier than to cross multiply, because then 8 times this is 24x squared plus 32x plus 16 is equal to 21x squared plus 28x plus 35. So then you take away 21x squared from the right side. That will leave you, when you take away 21x squared from the left side, it'll leave you just 3x squared on the left side. You have 28x's on the right side and you take it away, because your goal is to get 0. You take away 28x's from the 32x's, that leaves you 4x. And if you take away 35 from the right side, you have 0. And 16 minus 35 is negative 19. The same equation I got. And all I did was multiply by 3 over 3. That gave me this equation. And then I brought the 21 over. I multiplied 7 and 8 by 3. And then I did 2 minus 21. I didn't multiply that number by 8, that number by 8, that number by 8, and then each of these numbers by 7. That's 6 multiplications. 6 multiplications, and then I had to subtract. So I did 3 subtractions if you do it the way your teacher teaches you. And I got bigger numbers, 24, 32, 16, etc. Do it my way. You did 2 multiplications and 1 subtraction. Okay, it's a lot easier to do 2 multiplications and 1 subtraction than 6 multiplications and 3 subtractions. And again, well, not again, but I didn't say we're done. We just have our quadratic equation. I got mine doing 2 multiplications and 1 subtraction. Your teacher did it with 6 multiplications and 3 subtractions. And how you proceed from here, that's between you and your paper. Okay, I'm going to cut the video here. Try to think of clever ways of doing the problems that are taught in class. Good luck.